Hello everyone, myself Dr. Sonam Gupta, working as a professor in the Department of Computer Science and Engineering. Today we are going to discuss a complex topic in cloud computing, that is evolution of cloud computing. We will be looking at various aspects, how the cloud computing got evolved and how it is being used currently. So, for the evolution of cloud computing, it is all about renting the computing services, and the computing services can be the platform, software, infrastructure, anything. The idea about it initially occurred in 1950, and in making cloud computing what today it is reality, main 5 technologies play a very important role, and these are the distributed systems and its peripherals, the virtualization, web services, service orientation, and utility computing. So let's see these one by one. This is the evolution of cloud computing stack, how it is being used. So for this, suppose we are from 1950s, it got evolved from distributed computing, then came mainframe computing, cluster computing, grid computing, virtualization, web 2.0, service orientation, utility computing, and finally came cloud computing, which occurred from 2007 onwards. So this is how evolution of cloud computing took place. Starting from distributed computing, this was the first, we can say the topic, or we can say the first concept that evolved, and by facing different difficulties and making the advantages of the previous tier, we came across a very large path from this distributed computing to this cloud computing. So let's see what is distributed system was and what was the shortcomings in it. So it is a composition of multiple independent systems, but all of them, they are depicted as a single entity to the user. Now, what was the main purpose of distributed system? The distributed system was deployed to share the resources and then also use them effectively and efficiently. The distributed systems, they have the various characteristics, like they were scalable, concurrent, they were available continuously, heterogeneous in nature, and independent in the failure. But it also lacked some problems. Now, what was the problem they were facing? The main problem of this system was that all of the systems were required to be present at the same geographical location, and this needs to be solved. And because of distributed computing, it led to 3 more types of computing, which is mainframe computing, cluster computing, and grid computing. So by the help of distributed system, these 3 also evolved. Next is mainframe computing. For the mainframes, it came into existence in 1951, and they are highly powerful and reliable computing machines. They are responsible for handling large data such as massive input-output operations. Even today, they are used for bulk processing tasks, like we can say the online transactions. So for this, they can be used. And these systems, they have almost no downtime with high fault tolerance. And after distributed computing, these are increased. The processing capabilities of the system is also increased, but they were expensive in nature. So to reduce the cost, cluster computing was used as an alternative to mainframe. Next came the cluster computing. So in 1980s, after this mainframe, cluster computing, it became an alternative to the mainframe computing. And each machine in the cluster, it was connected to each other by a network having a high bandwidth. They were cheaper than the mainframes, and they were of equal high computations. And easily we can also add new nodes in the cluster if it is required. So the problem of cost was solved, but the problem related to geographical constraint was as it is. So to solve this problem of geographical constraint, grid computing came. Now grid computing came after this cluster computing in 1990s, and it was introduced for this heterogeneous problem. So it means that the different systems, they were placed at entirely different geographical locations, and they were connected through internet. Now these systems, they belong to different organizations, that means to the grids, and thus they are heterogeneous in nature. Although the problem of geographical location was solved in it, but it gave rise to another new problem, which is the distance between the nodes, which was increased. Now, to make this, that they encountered, it was low availability of high bandwidth connectivity was not there, and the network related issues were also there. So, cloud computing came into the scene, and cloud computing is also known as the successor of grid computing. Now, virtualization, so it was introduced about 40 years back, and it refers to the process of creating a virtual layer over the hardware, which allows the user to run multiple instances simultaneously on the hardware. And this particular technology is the key technology in cloud computing. So, it is based of major cloud computing services like Amazon EC2, VMware Cloud. So, all these work on this virtualization. So, hardware virtualization, it is the most common type of virtualization. Second, it is Web 2.0. So, it is the interface through which the cloud computing, it interacts with the clients. And because of this Web 2.0, we are having the interactive and dynamic web pages, because it also created flexibility among the web pages. So, the major common examples like Google Map, Twitter, Facebook, etc. So, social media, it also gained popularity during that period only. Next is service orientation. So, this is a basically reference model for the cloud computing, and it supports low cost, flexible and evolvable applications. And two more concept that was introduced during this was QoS, which is quality of service, and it also includes SLA, which is the service level agreement, or we can say software as a service, that is SaaS. Next is utility service. So, it is a computing model that defines service provisioning techniques for services such as compute service along with other major services like storage, infrastructure. So, these are basically provisioned on pay-per-use basis. So, these technologies, they contribute too much to the cloud computing, and today what cloud computing is because of these few technologies only. So, business drivers for adopting cloud computing. So, first one is the business hike. So, analyzing the moves giving the fabricated results. So, it gives you a certain range of hike in the business as well. So, it might be one of the cloud drivers. The growth in the business, it is one of the major obligations that any organization could ever read. So, before we step into the plan for driving the cloud services, so it is most prominent to boil out the business strategy, the consideration of cloud adoption, so which to be adopted. Second is the balanced cost structure. So, this is the one of the most recognized factors which acts as a driver for the cloud adoption. And the number of organizations they witness and they employ the cloud bolsters in cutting edge techniques, cutting the costs, licenses for the legal systems as well. So, depending on which type of service is required, which type of cloud is required, which type of space, software, infrastructure is required, we can easily adopt that particular cloud. Improvised productivity. So, when the organizations, they are adopting the means of fabricated technology, they are believed to view the tremendous change in the range of productivity. That's why only they are hiring those cloud services. So, productivity, it is a major factor which is considered as a driver for cloud adoption, because productivity needs to be increased anyhow. So, if the cloud, it is structured at a significant rate, then it could produce immutable results in the favor of the organization. Next is the efficiency. So, improved efficiency with minimal errors, it is one of the drivers which is propagating the reasons for adoption for the cloud. Now, when the organization, it adopts to any newer means of technology, it always has an underlying motive to access the medium for fulfilling that business requirement. Along with it, it also needs a hike in the business and optimized cloud solutions. So, this efficiency, it is about removing unnecessary steps of the processing thereby enhancing the productivity in the business and making the requirements for the customers to be satisfied at a faster pace. Scalability. The scalable service of the cloud, it is one of the biggest key driver which needs to be delivered in the favor of the organizations. The cloud enabled services, they are covered up in a manner so that one can scale the range of services as per its requirement. One can also add number of services to the customized features, and if the organization is ready, then they can also use that. And if the organization wants to step down of the terms and conditioning, then it is also far reaching the target. Next is the NIST model. This NIST model, it is a part of US Department of Commerce. And what is the work of this model? The work of this model is to promote the economy and public welfare by providing technical leadership for measurement and in standards infrastructure. So, from the NIST definition of cloud computing, we can say that cloud computing, it is a model which is used to enable ubiquitous, convenient, on-demand network access to a shaping pool of configured computing resources that can be rapidly provisioned and released with minimal management effort or service provider interactive. The NIST model, it provides various definitions of essential characteristics and the service deployment models for the cloud computing as well. So, for this, it can be used very easily. What are the essential cloud computing characteristics? First one, it is on-demand computing self-service. So, consumers, they can unilaterally provision computing capabilities as needed automatically without requiring human interaction with each service provider. Now, second thing, broad network access capabilities, they are available over the network and they are accessed through standard mechanism that is promoted by use of heterogeneous thin or thick client platforms. Next is resource pooling. The provider's computing resources, they are pooled to serve multiple consumers and using a multi-tenant model with different physical and virtual resources dynamically, which is assigned and reassigned according to the demand of the consumer. Next is rapid elasticity. So, customers, they need the elasticity as well. So, capabilities, it can be elastically provisioned and released to scale rapidly outward and inward commensurate with the demand. Next is measured service. So, cloud computing services, they automatically control and optimize the resources by using this leveraging meter capability at some level of abstraction which is appropriate to the type of the service which is required. So, now we are having various service models as well. So, cloud computing, we all know it is divided for three basic service models: platform as a service, infrastructure as a service and software as a service, that is this service PSAS, PaaS and IaaS. And the deployment models, we are having 4 deployment models, we have discussed this earlier as well: private cloud, community cloud, public and the hybrid cloud. So, these are the 4 deployment models that are being used. Now, if we will talk about one by one, infrastructure as a service, it is also known as hardware as a service, and it is one of the layers of cloud computing platform. It allows customers to outsource their IT infrastructure such as servers, networking, processing, storage, virtual machines and other resources. Customers, they can access these resources on the internet using a pay-per-use pay model. And in traditional hosting services, IT infrastructure, it was rented out for a specific period of time, and it is also have a predefined hardware configuration. The client, it will pay for the configuration and the time regardless of the actual use, and by the help of this infrastructure as a service cloud platform, clients, they can dynamically scale the configuration to meet the changing requirements, and then they are billed for the services they actually have used. So, cloud computing service providers, there are many more like Azure, which manages the infrastructure, while we purchase, install, configure, manage own software, operating system, middleware and the applications. So, this is the model which is being used. So, infrastructure as a service, platform as a service and software as a service. We are having hosted application and apps. Development tools are there, database management and business analytic tools are there, operating systems are there, servers and storage, networking, firewall, security, data center, physical plant and building. So, we are having various modules which comprises of all these things like software as a service, infrastructure as a service and platform as a service, and based on the combination of these three we are having cloud computing. So, infrastructure as a service, it has various services which are provided like compute, storage, network and load balancers. So, for the computing as a service, it includes virtual central processing units and virtual main memory for the virtual machine, and it is provisioned to the end users. For the storage, infrastructure as a service provider provides backend storage for storing the files. Network as a service, it provides networking components like routers, switches and bridges for the virtual machines. Next is load balancers. It provides load balancing capability at the infrastructure layer. Now, there are various advantages of infrastructure as a service. First one is the shared infrastructure. IaaS, it allows multiple users to share the same physical infrastructure regardless of buying all those infrastructure one by one by all the users. Second is web access to the resources. Infrastructure as a service, it allows IT users to access the resources over the internet. Third one, which is the major punch of cloud computing, it is pay as per use model. So, it provides services based on the pay as per use basis, and the users are required to pay for what they have used. Focus on the core business. So, infrastructure as a service provider, it focuses on the organization's core business rather than the IT infrastructure. And last one, it is the on-demand scalability. So, on-demand scalability, it is a major advantage of infrastructure as a service. Now, using this infrastructure as a service, the users does not have to keep worrying about whether the software has been upgraded, the troubleshooting. All the issues related to the hardware components will be handled by the infrastructure as a service only, and for that only we are paying to the cloud. Next is the disadvantages. Apart from having so many advantages, there are few disadvantages of infrastructure as a service as well. So, first disadvantage is the security. Security, it is one of the biggest issue in infrastructure as a service. So, most of the infrastructure as a service providers, they are not able to provide 100% security. Next is maintenance and upgrade. So, we know that the software part, it is maintained, the providers, they maintain their software, but they do not upgrade the software for some organizations. Some organizations, they are having the fixed software and they are not automatically upgraded by the cloud provider, which is infrastructure as a service. Third, it is interoperability issues. So, it is very difficult to migrate the virtual machine from one infrastructure as a service provider to the another one. So, for that also customers face a lot of problem related to vendor lock-in. So, these are the various IaaS infrastructure as a service providers. So, Amazon services, NetMagic Solution, Rackspace, Reliance, Sifi, Tata. So, all these are few infrastructure as a service providers which are being used. There are many more. So, this is an example of a simple pizza as a service. So, how this will take place. So, we have discussed this earlier as well. What is on-premise infrastructure as a service? If we talk about platform as a service, and if we talk about software as a service, so all these things will be taken of care by the vendor only. These green are the things which will be managed by vendors, and these blue include the things that will be managed by us. So, infrastructure as a service, it provides an infrastructure such as virtual machines and other resources like virtual machine, disk image library, file-based storages, firewalls, load balancers, etc. And there are very common examples include like AWS services, Google Compute Engine and all. Next is platform as a service. Platform as a service, it provides computing platforms which is related to operating system, programming languages, executions, environment, database, web server, and it is basically the top of infrastructure as a service. Examples again include Google App Engine, Stratos, AWS, etc. Software as a service, it is required to be provided access to the application services which are installed at the server side. So, we do not have to keep worrying about the installation, maintenance, coding, etc. That part will be done by the software as a service. We just have to use that software, pay as we are using it, that's it. So, all the Google apps, Google Docs, Gmail, Google Sheets, etc. These are simple examples of software as a service. So, we have seen in this slide how the cloud computing got evolved and what are the major criteria, major advantages, disadvantages through which the cloud computing got evolved. Thank you.